Our group consists of 3 members, which is Muhammad Hilmi bin Muhammad Hanafi, Muhammad Obis Naufal bin Abdullah, and Muhammad Irfan bin Abdul Halim. For question 1, Lina owns an antique valued at 90,000 and considering two options. Option 1, sell it now and invest the profit at 6% interest rate compounded quarterly. Option 2, keep the antique and sell it after 5 years for 110,000. Analyze which option provides a superior financial return. Support your conclusion with the appropriate calculation. Let's look for the answer for question 1. First, we must calculate the option 1. We extract the information from the question. P equal to 90,000, M equal to 4, K equal to 6%, T equal to 5 years. We are using compound interest formula, which means S equal to P, open bracket, 1 plus I, which means K divided by M, close bracket, to the power of N, which means M multiplied by T. We insert the information into the formula, and we get S equal to 90,000, and open bracket, 1 plus 6% divided by 4, close bracket, to the power of 4 multiplied by 5. And we set the equation into the calculator, and we get S equal to 121,260 ringgit and 95 cents. In conclusion, investing proceed through option A generates approximately 121,260 ringgit and 95 cents. It is higher than 110,000 ringgit and is thus a superior financial outcome. Lina stands to get 11,260 ringgit and 95 cents for selling now and investing at 6% compounded quarterly. For question 2, Rahmat deposit 1,500 ringgit into an account with an annual interest rate of 6.5% compounded every 2 months. After 3 years, he plans to make an additional deposit. His goal is to have a total of 6,000 exactly 2 years after the second deposit. Based on current deposits and interest, what should be the amount of Rahmat's second deposit? Discuss how compound interest and deposit timing influence the growth of his saving in this scenario. Let's look at the answer for question 2. We extract the information from the question. P equal to 1,500, K equal to 6.5%, M equal to 6. We must find the original principal of second deposit. First, we must find the total amount of first deposit. We are using the compound interest formula. S equal to P, open bracket, 1 plus I, which means K divided by M, close bracket, to the power of N, which means M multiplied by T. We insert the information into the formula, and we get S equal to 1,500, open bracket, 1 plus 0.065 divided by 6, plus bracket, to the power of 6 multiplied by 5. Insert the equation into the calculator, and we get the total amount of first deposit, 2,072 ringgit and 42 cents. We are using the total amount of first deposit to get the original principal of second deposit. 6,000 minus 2,072 ringgit and 42 cents equal to P, open bracket, 1 plus 0.065 divided by 6, close bracket, to the power of 6 multiplied by 2. Insert the equation into the calculator, and we get the final answer. Original principal of second deposit is 3,451 ringgit and 20 cents. In conclusion, the first 1,500 ringgit grows for the full 5 years, so it earns more interest. The second investment only earns for 2 years, so it must be closer to reach 6,000. In short, money grows more over time. Investing earlier reduces how much money you get later.
Now we are going to question 3. Siti deposits 9,000 ringgit into an account earning interest compounded semi-annually, reaching 11,500 ringgit after 4 years. First question. Calculate the annual interest rate that the account earns based on this growth. Based on the compound interest formula and semi-annual compounding, the annual interest rate for the account is approximately 6.22%. This means Siti's 9,000 ringgit deposit grew steadily over 4 years due to the effect of compounding.
I use the compound interest formula, which is A equals to R, bracket 1 plus K over M, bracket power of K times M. After substituting the values and solving the equation, I found that the annual interest rate is 6.22%. So, first, we write 11,500 equals to 9,000, bracket 1 plus R over 2, bracket power of 8. And then we calculate, and we will get 1.2778 equals to bracket 1 plus R over 2, bracket power of 8. And then, after we calculate it again, we got 1 plus R over 2 equals to 1.2778 bracket over 1 over 8. And then, after we substitute it, it will be R over 2 equals to 0.0311. And then, we'll get the answer is 0.0311. And then we times by 2, it will be
0.622, and we times by 100, and it will be 6.22%. Second, Predict the total amount if the original deposit is extended for an additional 2 years at the same rate. By extending the original deposit for a total of 6 years and applying the same annual interest rate of 6.22% compounded semi-annually, the amount grows to approximately 12,997 ringgit and 26 cents. This shows how compounding significantly increases the value of a long-term investment. Okay, so now the solution, we will write 9,000 ringgit, bracket 1 plus 0.0622 over 2, bracket power of 12. And if you press the calculator, I will get 12,997 ringgit and 26 cents. So for this part, determine the total interest earned over 6 years and discuss the key factors influencing this growth. As you can see, the solution is 12,997 ringgit 0.26 will minus by 9,000 ringgit and we'll get 3,997 ringgit and 26 cents. The total interest earned over 6 years equals to 997 ringgit and 26 cents. And the key factors influencing this growth include semi-annual compounding frequency, length of investment, which is 6 years, annual interest rate of 6.22%, and size of the principal. Question 4. Fadlan makes 50% down payment on a house price 700,000 ringgit. He borrows from a bank that charges 4.2% interest compounded monthly for 30 years. So part A, calculate his monthly mortgage payment based on the loan amount. The monthly mortgage payment is calculated to be 1,711 ringgit and 56 cents, showing the fixed amount the borrower must pay each month to fully settle a 350,000 ringgit loan at 4.2% interest over 30 years. As you can see, the solution is A equals to R, curly bracket 1 minus bracket 1 plus I, bracket power of negative n, over I, and curly bracket. And then we'll type in calculator 3,500 ringgit, 350,000 ringgit equals to R, curly bracket 1 minus bracket 1 plus 0.042 over 12, bracket power of negative 360 over and then over 0.042 over 12, and then we curly bracket, and if we press the calculator, we'll get 1,711 ringgit and 56 cents. And now part B, determine the total interest paid over the loan period. Over 360 months, the total amount paid significantly exceeds the principal, resulting in 266,000 ringgit and 161 ringgit and 60 cents in total interest. This demonstrates how long loan tenures greatly increase the total interest cost despite lower monthly installments. We press in calculator 1,711 ringgit and 56 cents will times by 360, and then we'll minus 350,000, and then we'll get 266,000 ringgit, 161 ringgit and 60 cents. And C, after completing the 250 payment, find the remaining balance if he opts to settle the loan early. After making 250 monthly payments, the remaining outstanding balance is still 156,000 ringgit, 41 ringgit and 37 cents. This highlights that in long-term loans, early payments mostly cover interest while the principal reduces slowly over time. And the solution is 1,711 ringgit and 56 cents, curly bracket 1 minus bracket 1 plus 0.042 over 12, bracket power of negative 110, and then we over 0.042 over 12, and then we curly bracket and we press in calculator, you get 156,000 ringgit and 41 ringgit and 37 cents. And for part D, if he misses the first two payments, analyze the amount payable on the third payment to clear errors and discuss possible consequences. The sum of 3 monthly installments amount to 5,152 ringgit and 67 cents, reflecting how consistent payments contribute steadily toward reducing the loan, even though the reduction in principal is gradual in the early years of the mortgage. And the solution will type in calculator 1,711 ringgit and 56 cents. We press curly bracket 1 plus 0.042 over 12, bracket power of 3 minus by 1, and then we over 0.042 over 12, and then we curly bracket and we get 5,152 ringgit and 67 cents.
For question 5A, calculate the total time in years needed to fully this loan. This part use the present value of an annuity formula to find the number of monthly payment required to pay off the principal. The calculation shown for n. First, isolate the negative exponent term. Second, solve for n using logarithms. So our answer is 5.69 years. For question 5B, Evaluate the impact of interest rates increase, decrease on the repayment period and total repayment amount. So we have our answer in 5A. After we calculate, we found out that the payment amount is increased. So monthly interest increase. So repayment period become longer, that makes the total amount paid increase.